I've got a 14 element UHF or 14 element 77 centimetre amateur antenna, a Yagi, up on the pole there, and I wanted to try and get some 2 meter repeaters. I want to get a bit further than just off a vertical J pole. Just looking at putting a Yagi, a 2 meter Yagi up on a cross arm. So I'll have the 70 centimetre Yagi 14 element and the 2 meter Yagi 13 element on the other side. So I dropped into see Ross up at Strictly Ham, there in Bayswater, I think he is, and got a pretty good deal on a Cushcraft 13 element 2 meter Yagi. They normally retail for $489. He knocked it down to $450 for me, which was a pretty good price. And I also bought a 2-position antenna switch. So the idea is to have the 2 coaxial cables coming down, and just next to my radio I'll have a switch so I can switch between the UHF or the VHF, or the 2 meters or the 70 centimeters. Because my 706, my Mark II 706 ICOM only has one input for both 2 meters and 70 centimeters. And instead of unscrewing the 70 centimeters and screwing the 2 meters in, would depend on what band I'm on, I thought I'd just get a switch. So he had a fairly decent quality switch for $89, and he knocked that down to $70 for me. So I picked both of them up for $520. So I thought that was a good bargain. So the plan is to pull the 14 element 70 centimetre Yagi down and just check it and make up a cross beam that I can put both the 14 element 70 centimetres and the 13 element 2 metre beams on, and then put it back up on the pole that I've got on top of the shed. But I want to test the SWR on the 70 centimetre Yagi before I pull it down, just so I can cross-reference that with when I put it back up. So I thought I'd do that with the video today. I'll show you my RigExpert antenna analyzer. This does from 0 to 600, hence why its part number is AA-600. 0 to 600 megahertz, and good piece of equipment. I use this all the time. It's fantastic. It cost me about $900 imported into Australia, with all the shipping and tax put on top of that. And it come from over in Sweden, I think it was. Could be wrong. I'm pretty sure that's where it came from, was Sweden. Actually, it might even say where it's manufactured on the back here, because, sorry, Ukraine. Yeah, Ukraine. Yeah, so it was directly imported from the manufacturer. Brilliant piece of equipment, love it. So I'll show you that as well, because we're going to test this UHF Yagi. I want to test it for well, the repeaters that around the repeater frequency that I use on UHF around this area. They're around 438 megahertz. So I'll test that on 438 and 433, see what the SWR is. We'll record that, and then when I put it back up, I'll check it again and see what it sits at. And I'll show you the Cushcraft 13 element 2 meter antenna, and I might even show you the process of building that as well. I'll get the switch and I'll show you the switch. So we've got our RigExpert connected up to our UHF coaxial cable that is connected to the 70 centimetre UHF 14 element Yagi that's on the pole on top of the shed, and we need to check the SWR before I pull it down, and that is a simple matter of setting the RigExpert to the correct frequency parameters. So we go to button 2. If if you can see that. Hang on, let me zoom out a bit. Okay, button 2, press button 2, and we set our centre frequency. At the moment our centre frequency is on 2 meters, so we need to change that to 70 centimetres, which is we'll set it for 435 for our centre frequency. And we want to go a couple of megahertz below that and a couple of megahertz above that, because our repeaters are operating at 438, 433, 439, 434 roughly, and so we want to go a couple of megahertz down and a couple of megahertz up to get our sweep. So we set our range, and we'll set, well, it's already at 5 megahertz. We'll set our range to 5 megahertz. Well, that's close enough. So we'll get out of that. And that's just a matter of pressing the free button. And then to check our SWR, to do a sweep on that antenna, we just press the 4 here, and we just go OK. So we press the OK button, and it will do our sweep. And we can see it has a bit of a dip here. It's not quite 1.5 to 1, and we're sitting at about 2 to 1 here. And we can go across with the arrow here. We go across, and we see our frequency up here is changing. And if we try and line up this arrow, or this pointer, to where the high point is, we can see our 2 to 1 ratio is around 433 megahertz. And if we go the other way, we can see our low point is around 436 megahertz. And if we wanted to zoom in further than what it is now to get a more accurate reading, we can change our range from the 5 megahertz sweep, which is 5 megahertz one side of the centre frequency and 5 megahertz the other side of the centre frequency. Sorry, no, correction, 250 megahertz, 2.5, sorry, 2.5 megahertz this way and 2.5 megahertz this way. The sweep is completely 5 megahertz in total. So if we want to zoom it in further than that, we could go down to 625 kilohertz sweep, plus or minus, and we go OK. And you can see that at 436.125 megahertz, we get a bit more of a more accurate reading on our SWR, and we can zoom in even further. So we can zoom into 78 kilohertz either side, and you can see that at 78 kilohertz either side of that 436.125 megahertz, it gives you a bit of an idea exactly where the SWR is. The idea behind that is if you're way out on your sweep, say if you're like 20 megahertz either side, it's harder to tell exactly where the SWR is at that point there. In fact, it even looks like we're not even on the pointer. We'll go across one, let's go back. So our two lowest points are roughly either side of there. But now if I see how it looks like it's more than 1.5, it looks like it's 1.7 or 1.7. Yeah, 1.7 it looks like it's at. If I zoom right in, go this way, zoom right in, you can see it's more of a 1.6. Well, it is over here anyway. And if you zoom out, you can actually pick your highs and your low points. So our two lowest points here, either side, if we go across with our pointer, It's about 431 megahertz, and that's around the sideband side of the band, narrow band, sideband, EME, all that sort of stuff. And this side up here, it's about 441 megahertz, so it's getting a bit high. The band that we're really interested in is around 438 and 433, which we're still 2 to 1. But we'll pull that antenna down and we'll have a look at it. I think the problem I have is the antenna's mounted too close to the actual pole. And when I put it on I'll put it on a cross beam with the two antennas mounted on a cross beam. I'll have it mounted further away from the pole, so that may even actually change our readings on the SWR. Okay, so we've got the Yagi off the pole. So it's 14 elements, 14 element 70 centimetre Yagi, and everything looks all right. A little bit of rust on the screws there. Oops, can't see there. Let me just zoom back down that way. It's a little bit of rusty screws there, but this is all full of silicon anyway, so it's not going to matter much. The old driven element's a little bit tarnished up. I might clean that up a bit, but apart from that, it's okay. It'll be interesting to see once it's on a cross beam. I've got my cross pole here. It's just I'll just put it down here. So it's about 2 meters wide, so I can have a fair bit of separation between the two antennas. And here's the 2 meter Cushcraft 13 element 144 to 148 megahertz Yagi. I'm yet to build that, and we'll get that built and put onto the cross beam or cross pole and mounted up on the pole on the shed. So it'll be interesting to see if our SWR improves on the UHF Yagi, and it'll be also interesting to see what these Cushcraft antennas give us in the way of SWR as well. Alright, so we got it finished. It's all together. Just one thing I found, we're putting the main boom together. There's 3 sections. There's a middle section and 2 end sections. The hole on this end section here didn't quite line up with the other side, so I had to drill it out a bit, but that's alright, we got that sorted out. Wasn't too much of a drama. We've got all the elements in line. They're a little bit out. If you look down the end, there's a couple that are sticking down, a couple sticking up. Just might need to tweak that a bit when it's in the air. And I've got the cross beam here, a cross pole on there, so I'll slide that up and put it. So I'm going to have it vertically polarised, and that's it. And we'll have the UHF one up as well on the other side of that cross arm. So this one will be up here, and I'm not sure what I was saying now. I got a phone call and it stopped me from recording. I think I was saying that this will slide up to about here, about there, and the UHF or the 70 centimetre one will be down that end there, and then this will be on the pole tilted that way on the top of the shed, and both the VHF and UHF will be vertically polarised. There's a little puppy. He's having a bit of a whinge. Hey? Oscar. 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 Having a bit of a whinge. He's outside at the moment because we're cleaning up some of the stuff that he's made a mess in the house. So just got him out here for a minute. Alright, so next section of this video you'll see it up on the pole. Well, good morning everybody. Next day I've got the 13 element 2 meter Yagi on the top part of that cross arm, and I connected up a cable here onto our analyzer, and we're just going to check it while it's on this pole in the shed. Just going to check the SWR, see what we get. So we need to change our frequency. 140, let's say 145. We'll go 145. Okay. And we need to check our range. Our range is 20 meg. Change that to 5 meg. So it will be 2.5 meg either side. Okay. And let's check our SWR. 4. And let's go. Oh, look at that. It's pretty good. Now let's just have a look where this low point is here. So the low point there is about 144 meg, thereabouts. And the other low point is 147 megs, roughly. And what we're aiming for is 146.6 and well, 146.1 and 146.7 is the repeater I'm after. And that's pretty good. That's like it's 1.2 to 1. Not too bad. I'm not going to complain about that. It's not even up on the pole yet, so it should be better once it's up on the pole. Well, I got it up there. The biggest trouble I had was trying to get it over the guide wires on that pole. But we got it. So I need to check the SWR. And the other thing on the agenda is to remove this link. Temporary link I've got here on a 15 metre pole. One of the admin staff was working remotely, and I had to provide them with an internet connection and telephone VoIP connection. And the only way I could get a connection to her place, which was about 18 kilometres away, was to put it on a 15 metre telemast. And she's back at the shop now, so we can remove this link sometime soon. I had to use a support on that Yagi. It's a little bit heavier than the UHF. The VHF weighed a bit more and it was dragging the end down. So I've just put a support on there and let's fix that up. Okay, so let's check the SWR now. That's up in the air. Should already be set for the frequency we want. We'll just check that. Yeah, 146 is our center frequency. And 5 megahertz, which should give us 2.5 megahertz frequency range down and up from the center. Hit the SWR, which is key 4, and hit the go button, this one. Oh, wow, that's pretty good. Where's our SWR start to lift up off here? 145 megahertz, and at 144 megahertz we are sitting at about 1.2 to 1. It's not bad at all. And up the top part of the scale here, where does it lift off? Takes off at about 146.6 megahertz. And top of the scale, 148, we're sitting just above 1.2 to 1. I'm happy with that.